Hello, this is Cora from CUH Vibratory Feeder Controller Manufacturer. Today I'm gonna demonstrate this new controller. It is called the SDVS31 Intelligent Dual-Fibre Line-Scan Sorting Controller. It's this one. So, firstly, you need to power it on. So you need to give a 24 volts power. Let your PLC output connected to the 24 volts port in this controller, and then connected the earth. So the red line is the power or the output from PLC, and the black wire is the earth. Then here is the air inlet. By default it is a 6mm diameter tube. Come here to this side. Here are two optical fiber sensors. You see? Two sensors here, and then you can see if you check closely to the line, one line is of many dots. So this line of many dots is to send the signal, and it is connected to here the T, here marked T. And this line with this wire without dots is to receive the signal. You need to plug it into the hole that is marked with R. So T is for the signal out, and R is for the signal receiving. The second one is all the same. And here is this knob is to adjust the air blow. More bigger or more light. And this is air outlet. This fiber sensor and this air outlet tubes are included in the package.
Okay. Hi everybody. Today I will going to show you how to allow some pieces to pass. In here in my hand we have a pieces which can be goes with 4 directions. With this direction, this one and this one. This is 4 direction. And in this device I will show you just one way is pass. This is this one. Let's set up the device. This is one direction that I'm gonna allow. This is first example. I will use 7 example for this device. This is one, it's allow. Two, sorry. 3, 4, 5, 6, 7. Yes, 7 times I take the example, and device keep it on the hard way, soft way. Now this is the second example. I will show this way. This is first example. This is 1, 2, 3, 4, 5, 6, and 7. And I'm gonna remind you
Okay, so this is the
first.
direction.
First, this is the second
This is
direction.
the second direction.
And guys, I will take 7 example for each direction. I will take 7 example for each direction. This is third one. Third one have to be like this. Have to be like this. And here is first example. I'm gonna take it. 1, 2, 2, 3, sorry, it's mistake. I'm going to, this is the 4, 5, 6, and 7 for each one. Now, fourth one. It can take time to adjust it. This is the fourth direction.
Now the fourth, the last direction.
1 example. 2, 3, 4, 5, 6, and 7. Yeah, I took 7 examples for each direction. Now I'm keeping it on the hard way. After all the setup, I'm pressing both of them together. Now let's test it.
That means the accuracy, the controller shows that accuracy is estimated to be 99.92%. Now let's
Yeah, now
see the first direction, this one. Second direction, this one. The third direction, this one. So should be the first direction pass.
and also we can see in here which one is pass. If I want first one is pass, there have to be right P. If I want it's not pass, I'm pressing to set and it's being abandoned. But for now, for testing, I want this direction is pass. So I'm gonna make it to pass. Pass and press these two together. Now let's see. First one is pass. 2 is abandoned. 3 is abandoned. 4 is abandoned. Now let's take a look. How does it work? This is the example one. I'm going to use third one and in this way. There is right in one pass. And second example. Second thing, there have to be right one pass. But there can be accuracy. 2 is pass. That's not good. Take a see how will it work. One example. It's a good. One pass. There is right in one pass. one pass. You can also, on the device there will be writing one pass when it's true. There is writing one pass. Now this is just example, one pass. Now in this way, it will be abandoned. Two is abandoned. You can see guys, air is working. This is two will be abandoned. And fourth, it will be abandoned. It's abandoned. That's it guys. Everything is done.
So this is pass, right?
Yes, this is pass. And there will be writing one pass when it sees. It pass. You can also show this.
Pass. And this is abandoned.
Abandoned.
This direction is abandoned. The back side, this direction should also be abandoned.
And now again, first direction will be pass. And there will be writing first one is pass on the device. You can see in the device there will be writing first is pass. First one is pass. That's it guys. That's it. You are welcome.
Another thing we should pay attention is that about which valve you need to blow. As we see here is sensor A and sensor B, and valve A and valve B. So we connect it here. This is sensor A, this is sensor B, and valve A is more near the sensor. Valve B is apart from the sensor. Then, if the parts come in for some light parts, only valve A blow, it will be blown away, right? But for some heavy parts, like this one, long parts, like this is long part, and only valve A will not blow it off. So you need valve B also to blow. Then how you set it? You can set here for group A, which has the valve A. You set. You press set and up button, and you choose E dot is the first single of valve A. E is the second single of valve A, and N is the logic. Logic is OR. So you make it E dot to be 0 and E to be AB. This makes the valve A start to blow. We want to the valve B, the second air valve B to blow more time. Then we short press this button to change to group B. Then we again, this is the first single, second single, and logic, but we just leave it by factory default value. This one is the falling edge delay time. Means the if you want the air to blow more time, more seconds, then you need to change this value. Now it is 0.6 seconds. I can change it, increase it to be more. So So now if one reject it, you will see it blowing long time, right? This is group B, means this part, this valve B, this hole. Group A, the air blow comes from this hole. Normally your sensor should be assembled at half of the part distance from the valve A, so that when it starts to blow, the parts is just at the valve is just at the middle of the part, right? So the distance from the sensor to the valve A is just half of the part's length. But as you see, this part is maybe heavy or maybe too long, then you need valve B also to blow off. Then you come to group B. You choose you choose the E dot to be AB, E to be FLH, 0 to be O, not to be O. This is to make a B also blow with A. This on rising means slow to means on delay to blow. This is blow off delay time. Okay, 1 second now. 1 second now. So more time. Hello everyone, this is Cora from CUH Laboratory Feeder Controller Manufacturer. Now I'm going to talk about the SDVS31 series. It's an intelligent dual-fibre line scan sorting controller. So it consists of 4 groups. Group A, B, C, and D. Group A includes the optical fiber sensor, solenoid valve inside the controller, and group B also another optical fiber sensor and a solenoid valve inside. Group C is, if you open the cover, you can see the single ports. Group C including single ports and 24 volts DC output ports for you to connect with your solenoid valve or your cylinder. Group D as well. So here is the diagram of it. So the power of this controller is you need to connect the ground to your PLC ground and your PLC output to the 24 volts port. And this is DC output P for at group C, and this is DC output D at group D. Sensor E and sensor C are for group C and group D. This is you need to use another sensor like MPN or PNP sensor. These are input and output diagrams of port C and E, port D and P. Here, this means the standby parameter. We have this This one means NP means display the current orientation number of the parts and whether it needs to be rejected. NP and NA. P means pass, A means reject. And the detected length. These two parameters is to tell you that for this controller, if it has the same shape, if the part is at the same shape but only different lengths, then you can set the length tolerance to make the controller to sort the parts that with the same shape but different lengths. You can also sort out the parts in a certain direction, even if it has different lengths. So it is shown here by this parameter, the length tolerance. Then we have the monitoring parameter, which you can long press, set and down button. All these parameters you cannot change, but it can tell you, it's just like a monitoring parameters, it can tell you all the values that it is running now. That feedback to the controller itself. Then here we got the parameter group AB value. This one below means whether to allow the unload parts to pass through. If you choose 0, that is reject, means if the parts value that you have never let the controller to learn about, it will be rejected or be blown off. If you choose 1, that means any parts that is not learned by the controller will be also accepted and passed. Normally, by default, we can choose 0. Parameter group A and B is that when you long press set and up button, that you can see all these parameters. If you want to change from A and B, there's a button on the cover. Later I will show you. These are parameters C and D. This value, this FL value, I want to talk about is the allowable tolerance for the length of the part or the time taken to pass through in unit of 1%. Means the allowable tolerance that you can set to let the controller more strict to sorting the parts, or give it more tolerance to sort out the parts in the certain direction that you want. This one, also there is important one is the E dot, E and N. And this is E dot is the first singular source. E is the second singular source. This is the singular source of the air walls, the air of walls inside. Like in group A, if you want the valve A to blow, it listens to the E dot and E value after the logic N. Normally, you just need to set it by default value. And also the group B, the valve B, is also have its own E dot and E value. There is the output signal rising edge delay or falling edge delay. Normally, if you want the air valve to blow more time, not 0.1 second as per factory default value. If you want it to blow like 0.8 seconds for some heavy parts, you can set the output signal falling edge delay, this parameter, and should be long. And here is the reset to factory default value. Is when you long press the circle button and the down button, you can. This is for parameter groups A and D. For the group A and B, you also have a reset to factory default value. So this reset is as per group. We have 4 groups, so we have 4 reset to factory default value. With this SDVS31 controller, you don't have to find the P and P dot value. You don't have to find the reflective value by yourself. The controller will do an intelligent artificial learning by itself. You just need to pass the part for several times to let the controller learn by itself. It will know the value. It's using its line scan, using its dual-fibre sensor and a line scan sorting. This is the basic operations. This parameter means how many parts it detected already. It's a total value. This is 1P2. I will explain what it is. The 1 means the first direction. You have totally 4 directions maximum. The P means pass. It can change to A as well. A means reject. 2 means the second time you let it learn. You can let the controller to learn maximum 10 times. And after learning, it will show you the A value. A represents that the estimated accuracy. It will show you the controller, and after learning by the controller itself, how it think that its accuracy for these parts according to your operation this time.